Welcome back, everyone, for another deep dive. This time we're taking a look at generative AI.
Yeah, one of the most fascinating and rapidly developing areas of AI today, I'd say.
Definitely. I mean, AI that doesn't just analyze, but actually creates things,
Mhm.
that still just blows my mind.
Absolutely. And it's not just some far-off science fiction anymore. Generative AI is already being used to create everything from realistic images and text to original music and even code.
So like having a digital artist right at your fingertips. But where did this all begin? I know AI has been around for a while, but this creative aspect seems relatively new.
Well, you're right. The foundations were laid decades ago with early probabilistic models and neural networks, like those hidden Markov models we were using back in the 70s and
Ah,
80s.
yes, HMMs. I remember those. Vaguely. But things really took a leap forward with the arrival of GANs, right? Generative Adversarial Networks in 2014.
Exactly. GANs were a game changer. They introduced this idea of two competing neural networks, a generator trying to create realistic content and a discriminator trying to spot the fakes.
So like an AI art forger and an art detective, constantly trying to outsmart each other.
Yeah. And through this adversarial process, both networks improve. The generator gets better at creating convincing fakes, and the discriminator gets better at detecting them. It's a constant arms race that leads to some truly impressive results.
I can see why that competition would drive innovation, but GANs are just one type of generative model, right?
Yeah.
What other approaches are there?
Oh, there are quite a few. Another fascinating approach is VAEs, or variational autoencoders.
VAEs, how do those work?
Instead of competing, VAEs learn to compress data into a smaller, hidden representation called the latent space. It's like finding a secret code that captures the essence of the data.
Okay, so instead of directly copying, they're learning the underlying structure of the data.
Precisely. And by tweaking the values in this latent space, we can generate variations of the original data, leading to all sorts of creative possibilities.
So we have AI that can compete and AI that can condense. What other tricks do these generative models have up their sleeves?
Well, there's also autoregressive models, which take a more step-by-step approach to creation. They generate data one piece at a time, using the information from the previous steps to predict the next.
So instead of seeing the whole picture at once, it's like building a puzzle, adding one piece at a time.
That's a great analogy. Think of pixel RNN or pixel CNN generating an image pixel by pixel or wavenet, creating audio sample by sample.
It's amazing how these AI systems can mimic the way humans create things. But I'm guessing they need a solid foundation before they can start composing symphonies or writing novels, right?
Absolutely. We need to teach them the fundamentals of machine learning first.
It's like learning the alphabet before you can write a book.
Exactly. And one of the first things an AI needs to learn is the difference between supervised and unsupervised learning. You see, in supervised learning, we give the AI labeled data. It's like giving it the answers along with the questions.
So it knows what's right and wrong, like teaching a dog a trick with treats.
Yeah. But with unsupervised learning, the AI has to figure things out on its own. There are no labels, no right or wrong answers. It's more about finding patterns and making connections in the data.
So like letting a child explore a box of toys and discover how they work together.
Exactly. It's about letting the AI explore and discover on its own.
Okay, so supervised learning is about guidance, and unsupervised learning is about exploration. And once our AI has mastered these learning styles, what's next?
That's when we introduce neural networks, those interconnected networks of artificial neurons that mimic the structure of the human brain.
So it's like building a digital brain, one tiny connection at a time.
Yes. And as these networks become more complex, so do the AI's capabilities. They can start to perform tasks like image recognition, natural language processing, and even decision making.
Okay, neural networks, got it. But wait, there's more, right? What about probability and statistics?
Oh, absolutely. Probability and statistics are crucial for AI systems that need to make predictions and deal with uncertainty.
So like predicting the weather or understanding the stock market.
Exactly. Probability helps us determine the likelihood of something happening, while statistics helps us analyze and interpret data. And this is all essential for AI systems to make sense of the world around them and learn from experience.
So now our AI has a grasp of machine learning, probability, and statistics. It's ready for boot camp. I'm ready to see these generative models in action. What can they really do?
Yeah, let's delve into the exciting world of GANs, VAEs, and all the other amazing generative models. Get ready for some mind-blowing creativity.
Okay, so we've prepped our AI recruits with the basics. Now let's see these generative models in action. Let's start with those GANs, the ones battling it out. What kind of creative things can they make?
Well, Shans are already making quite a name for themselves in the AI art scene. They're generating some really realistic images and text that sounds like it was written by a human.
Wow, so AI can be creative. But how do these GANs work? Can you remind me how the generator and discriminator do their thing?
Remember the art forger and the art detective we were talking about earlier? Well, the generator is always trying to create fake data that looks super real, while the discriminator tries to sniff out those fakes.
So it's like a constant battle of wits, right?
Hmm.
Each one pushing the other to get better.
Exactly. And as they go back and forth, the generator gets better at fooling the discriminator, and the discriminator gets better at detecting those fakes. It's like an AI arms race to create more and more realistic content.
It's amazing how this competition actually drives innovation. But Jans aren't the only cool kids on the block, right? What about those VAEs? They seem pretty impressive, too.
Oh yeah, VAEs are fascinating. Instead of a head-to-head battle, they take a different approach. They learn how to encode data into this compact representation, sort of like a secret code.
Their secret code.
Yeah, it's called the latent space. It's like boiling down the essence of the data to its core elements.
So it's not just copying. It's more like understanding the underlying structure
Yeah.
and then rebuilding it.
Precisely. And by tweaking those values in the latent space, we can create all these variations of the original data, leading to new images, sounds, even molecular structures.
It's like having a set of controls for the data. You can adjust them and see what new possibilities emerge.
That's a great way to put it. And this ability to explore different variations makes VAEs really useful for things like anomaly detection, finding those data points that don't quite fit the pattern.
Okay, on to those step-by-step creators we were talking about, the autoregressive models.
Yeah.
Pixel RNN and Pixel CNN, they generate images pixel by pixel, right? It's like watching an artist meticulously create a painting, one tiny dot at a time.
Yeah, it's quite remarkable. They use the information from the pixels they've already generated to predict the next one in the sequence, building the image piece by piece.
And what about WaveNet? It sounds like it could revolutionize how we create and interact with audio.
Oh, absolutely. WaveNet is an amazing example of an autoregressive model applied to sound. It can generate speech, music, all sorts of audio with incredible realism. It works by predicting the next audio sample based on the previous ones, capturing those subtle nuances that make it sound so natural.
So more natural-sounding virtual assistants, text-to-speech systems that are indistinguishable from a human voice. Maybe even AI-composed symphonies.
The possibilities are vast. And speaking of AI composing, we can't forget about GPT, or Generative Pre-trained Transformer, the king of text generation.
Oh yeah, GPT-3, the AI that can write everything from code to poetry. It's pretty mind-blowing. What's the secret to its success?
Well, GPT is a transformer-based model, meaning it uses this powerful mechanism called self-attention to really understand and process text. It's been trained on this massive data set of text and code, which allows it to generate these incredibly coherent and contextually relevant outputs.
So it's like it's absorbed all this information and now it can weave together words and ideas like a master storyteller.
That's one way to look at it. And GPT-3 and the models that came after it are really pushing the boundaries of what's possible with AI, blurring the lines between human creativity and machine creativity.
Okay, let's move on to those flow-based models. They sound kind of mysterious. What's so special about these normalizing flows?
Well, think of them as masters of transformation. They're all about taking simple distributions and gradually morphing them into complex ones, like shaping a lump of clay into an intricate sculpture.
So complete control over the creative process, seeing how each step affects the final outcome.
You got it. One example is Real NVP. It uses a sequence of these coupling layers to gradually transform the data distribution. It's really quite ingenious.
And then there's Glow. I've heard it can generate incredibly realistic images that rival those made by GANs.
Yeah, Glow is known for both its efficiency and the quality of its output. It uses these invertible one-by-one convolutions, which allows it to learn those intricate relationships within the data without losing any information along the way.
It's like a magician who can pull a rabbit out of a hat without revealing the trick.
Exactly, and it's amazing how many different approaches there are to generative AI, each one with its own strengths and its own potential applications.
It's almost overwhelming. But before we get lost in the world of models, let's take a quick detour to talk about transformers and attention mechanisms. I keep hearing about them everywhere these days.
Oh, you're right. Transformers have really revolutionized many areas of AI, especially in natural language processing. They leverage this amazing concept called self-attention, which lets the model focus on different parts of the input when it's processing each element.
So instead of processing words in a sentence one by one, it's like the AI can see the whole sentence at once, understanding how each word relates to the others and the context.
Precisely. It's as if you're reading a sentence and you have these little footnotes connecting each word to other relevant words, giving you a deeper understanding of the meaning.
I can see how that would be so powerful for things like translation and text summarization.
Yeah.
But are transformers limited to language?
Nope, not at all. They're being used in all sorts of areas like image processing and even protein folding. They're very versatile.
Wow. Talk about a multi-talented tool. Okay, now I'm really curious about reinforcement learning and generative AI. How do these two powerful technologies work together?
Well, reinforcement learning, or RL, it's all about training an AI agent to make decisions to get the best reward. Think of it like teaching a dog a new trick by giving it treats when it gets it right.
Because instead of giving the AI specific instructions, we're letting it learn from its own successes and failures.
Exactly. And generative models are super useful in RL. They can create realistic simulations for these AI agents to train in.
So the AI can practice in a safe environment without real-world consequences.
You got it. A really good example of this is AlphaGo, the AI that mastered the game of Go using a combo of reinforcement learning and generative models.
That's amazing. And the applications go way beyond games, right?
Oh, yeah. Think of things like training self-driving cars in virtual worlds or designing new drugs using simulations. It has huge potential.
Okay, last but not least on our list of generative AI wonders are diffusion models. They're creating some amazing art these days. How do they do it?
Well, they do it in a kind of backwards way. Imagine taking a clear picture and slowly adding noise until it's just a blur. That's what diffusion models do to the data initially.
So they corrupt the data on purpose.
In a way, yes. And then they train a model to reverse this process to denoise the data step by step.
So it's like teaching the AI to clean up a messy room. And in doing so, it learns how to create order out of chaos.
That's a good way to think about it. And by mastering this denoising process, diffusion models can create some really impressive images. They can even rival GANs in terms of quality and diversity.
That's pretty incredible. And one of the most famous diffusion models is DALL-E, right? The AI that creates images from text descriptions.
Yeah, DALL-E is remarkable. It can take something like a cat wearing a top hat riding a unicycle and create these unique images that match the description.
It's like having an AI artist that can bring any idea to life, no matter how wild or wacky it is. But before we go too far down that rabbit hole, let's talk about the practical applications of generative AI. How is it already changing the world?
Well, generative AI is already making a big impact in lots of industries, like natural language processing for one. We're seeing it in text generation, chatbots, translation tools.
It's making communication and creating content way more efficient and accessible.
Absolutely. And in computer vision, generative AI is changing things like image generation and style transfer. It's finding applications in art, design, photo restoration, and lots more.
The possibilities seem endless. And what about audio and music?
Oh, yeah. It's transforming how we compose, synthesize, and enhance sounds. It has applications in entertainment, accessibility, even scientific research.
And let's not forget healthcare. Generative AI is being used to design new drugs and create personalized treatment plans.
It's really exciting to see how generative AI is being used to solve real-world problems and make our lives better.
We've covered a lot of ground in this deep dive into generative AI, and I'm really impressed with what we've learned.
Me too. It's amazing how far the field has come in just a few short years.
It really feels like we're just at the beginning of what generative AI can do. It's pretty exciting. But where do you think this is all headed? Any cool trends on the horizon?
One that I'm watching closely is the rise of these AI tools that anyone can use. More and more platforms are popping up that make it easier for people without a tech background to play with and create using generative AI.
So you don't need a PhD in computer science to make AI art or write a song with AI anymore.
Yeah, exactly. And this opens up a lot of creative possibilities for artists, writers, musicians, basically anyone who's interested in using AI to explore new ways of expressing themselves.
It's like putting a whole new set of tools in the hands of creators.
I think that's a great way to put it. And another trend I find really fascinating is the development of these multimodal AI systems. We're starting to see models that can combine different types of data seamlessly, like text, images, audio, even video.
So instead of just creating text or just creating images, you could have an AI that creates a whole multimedia experience.
Right. Imagine AI systems that can generate entire stories, complete with visuals, music, sound effects. It's like having an AI director who can bring all these elements together.
That's pretty mind-blowing.
Mm.
But as these AI systems get more sophisticated, I think it's also important to address the potential risks and challenges.
Yeah.
Like, how do we make sure generative AI is used ethically and responsibly?
You're absolutely right. It's a powerful technology, and as with any powerful tool, it can be misused. We need to be really thoughtful about how we develop and deploy these
Well, it's
models.
like giving someone a powerful paintbrush.
Yeah.
It can be used to create beauty, or it can be used to spread misinformation.
Yeah, exactly. So we need to be aware of these risks and work on strategies to mitigate them, like developing guidelines for ethical AI development and encouraging responsible use of these tools.
And it's not just about preventing misuse. It's also about making sure these AI systems are accessible to everyone and that they benefit society as a whole.
Absolutely. We need to work towards a future where generative AI empowers people, fosters creativity, and helps create a more equitable and inclusive world.
So it's not just about the tech itself, but about how we use it and how it shapes our lives.
That's a really important point. And for anyone who's listening who's interested in exploring the world of generative AI, stay curious, stay informed, and stay involved in the conversation.
I couldn't agree more. The future of this tech is in our hands, and we need to make sure we're shaping it wisely and responsibly. Well, that wraps up another fascinating deep dive. Thanks for joining us, everyone.
Thanks for having me. It's been a great conversation.